Hey guys, today we're going to further our understanding on simplifying radicals, particularly adding and subtracting and multiplying. But before we get there, let's review a little bit. So here I have the square root of 32 times x to the fifth times y squared. Now, using the properties that we have already learned with the product of radicals, I can break this up as so. And I can't take the square root of 32. However, I do know that 32 is 16 times 2. And this helps me because the square root of 16 is 4. The square root of 2 is left alone. And there. Now let's take a look at the square root of x to the fifth. Well, I can't divide 2 from 5. So I'm going to take the square root of x to the fourth times the square root of x to the 1. And the square root of x to the fourth is x squared times the square root of x. Now the square root of y squared is simply y. Putting this all together, we will get 4x squared y times the square root of 2x as my final answer. Great. Now let's take a look at the next one. We have the square root of 8 over 27. So remembering the quotient property, I have the square root of 8 divided by the square root of 27. I cannot take the square root of 8, so I'm going to break that up as the square root of 4 times the square root of 2. 27, I'm going to do the same, but in this case I'm going to do the square root of 9 times the square root of 3. And I will get 2 times the square root of 2 divided by 3 times the square root of 3. Hopefully you remember that I cannot leave my radical in the denominator, so I need to multiply by a factor of 1 to get rid of the square root. So I'm going to do that in a different color. The square root of 3 divided by the square root of 3. This will join these two values, as you'll see here, and that'll give me 2 times the square root of 6. Square root of 2 times the square root of 3 is the square root of 6, divided by 3 times the square root of 9, because the square root of 3 times the square root of 3 is the square root of 9. So, almost done. Now the square root of 9 is 3, so I will get 2 times the square root of 6 divided by 3 times 3. Give me an answer of 2 times the square root of 6 over 9. And that is how to simplify radicals in these two forms. Now, we're going to be performing operations with radicals. Here I have the expression 5 times the square root of 7 plus the square root of 11 minus 8 times the square root of 7. Now hopefully this isn't too daunting, but if it is, I promise you, you already know how to do this. Here's an example that is very similar to the expression I gave you above. Here I have 5x plus y minus 8x, and we are going to combine like terms. Here I have 5x minus 8x, which will result in negative 3x. I don't have any like terms with the y, so I'm simply going to put it next to each other. Great, simple, right? Now here I'm telling you it's the same thing. However, if x was equal to the square root of 7 and y is equal to the square root of 11, that will be exactly what we have here. And so when we simplify, we can join like radicals, just like we can join like terms, like we did here. So in order to do that, I'm going to rewrite this. I don't have to rewrite it every time, but just for the first time as we're learning how to do this, I'm going to rewrite it and see how I have like radicals. I have the square root of 7 and the square root of 7. And I'm going to combine them just like I did in the other example. 5 minus 8, still negative 3 times the square root of 7. And I don't have any other square root of 11s, so I'm going to simply put plus the square root of 11. And that's it. So you are going to look for like radicals, combine them using the operation, addition or subtraction, the same way that you would do this. If for any reason it becomes cumbersome and it's hard for you to understand, feel free to change your expression as x, y, and x. Then it'll turn into that. Just make sure you understand to put the radicals back into the expression as your final answer. So, performing operations with radicals. Here is the explanation. Pause the video if you need. Write this down in your notebook. Great. So, just like you saw in my previous example, you can add or subtract like radicals the same way as you would combining like terms, and by using the distributive property that you will see very soon. So, let's add and subtract some. Here, we're going to go back to this example, but I want to show you a different way of taking a look at it. So I'm going to rewrite this so that all my like radicals are exactly the same. And noticing these two, I can factor out the square root of 7 of both. So if I divide square root of 7, divide square root of 7 on both sides, I will then get this. Just get this out of the way. And now that square root of 7, I'm factoring it out, putting it up to the right, and you'll see that I still have 5 minus 8 left over because these equal to 1. And then I will have negative 3 times the square root of 7 plus the square root of 11. The same answer that we did before. So 3 different ways of doing it with the same exact answer. Here we have something a little different. So you should automatically see that I don't have any like radicals. However, you should know how to simplify the square root of 20, and hopefully we will get like radicals so that we can add these. So let's take a look. Here, I cannot change the 10 times the square root of 5. However, I can rewrite the square root of 20 as the square root of 4 times the square root of 5. And something should click. Square root of 5, it's on both terms, so that's good. I'm going to bring down the 10 times the square root of 5 because I'm not using it yet. And the square root of 4 is 2 times the square root of 5. And look what happens. We have like radicals now. So I can combine them using the addition operation. 10 plus 2 is 12 times the square root of 5. And that is your final answer. Now, let's take a look at distribution or multiplying radicals. So here I have the square root of 5 times the quantity square root of 3 minus the square root of 75. So I'm going to distribute the square root of 5 to every term in the parentheses. In this case, both of these. And I will get square root of 5 times the square root of 3 minus the square root of 5 times the square root of 75 by the distributive property. That will give me the square root of 15 minus the square root of 375. Unfortunately, the square root of 375 is 19.3649, and it'll go on forever because it's irrational. However, I can break this up. Square root of 15 minus the square root of 25 times the square root of 15. And this is perfect because the square root of 25 is 5 times the square root of 15. You'll see that here. Now I can combine like radicals the same way, again, like you would combine like terms. And I have 1 minus 5 to get me negative 4 times the square root of 15. And that's my final answer. And I am done. So, let's take a look at this. I have the square root of 2 times the square root of 45, square root of 2 times 5. This will give me, let me work down here, the square root of 90 plus the square root of 10. Great. Now let's take a look. The square root of 90 I can break up as the square root of 9 times the square root of 10. The only multiples of 10 is 1 and 10 and 2 and 5, all of which are not perfect squares, so I'm going to leave the square root of 10. So the square root of 9 is 3. Like I previously stated, the square root of 10 is simply the square root of 10. It is irrational. And now again I have like radicals, so I can say that my final answer is 4 times the square root of 10. Hopefully you're catching on. So let's take a look at something a little bit different, but it's the same. We already know that x squared is x times x. So looking here, I have a binomial squared, and if you remember our lessons in quadratics, we've seen this a lot. So I can rewrite this expression as 2 times the square root of 5 minus 4 times 2 times the square root of 5 minus 4. So taking a look here, I'm going to use the FOIL method, or a double distribution. I have 2 times the square root of 5 times 2 times the square root of 5, and I will get 4 times the square root of 25 because of 5 times 5. Now I have 2 times the square root of 5 times negative 4, which will give me negative 8 times the square root of 5. Let's take a look at the others. Negative 4 times 2 times the square root of 5 is negative 8 times the square root of 5. And lastly, I have negative 4 times negative 4 to give me a positive 16. Perfect. Now a little bit more to go. The square root of 25 is 5. I have like radicals. So negative 8 minus 8 is negative 16 times the square root of 5 plus 16. And now I have to combine the 4 times 5. So my final answer, or close to my final answer, is this. And again, I have like terms. And so I will get 36 minus 16 times the square root of 5 as the final answer. 20 plus 16 is 36. You can't do anything more with the negative 16 times the square root of 5, so I bring that down. That's it. Great. That is it for this week. That is it for today. Hopefully that was enough. If anything was confusing, please feel free to reach out to me or rewind the video and watch it again. Bye.